All right, so now in this video we're going to talk about. So welcome to District Learning Institute. Like we said, my name is Tajuma and we'll be solving questions for test 1 preparation. Okay, so our first question for today, it's saying that let f of x be equals to, so we have f of x which is equal, so f of x in this case is equals to 2 minus x. Then g of x, as they've mentioned, it is g of x is equals to the square root of 1 minus x squared. Then now they're saying that evaluate. So to evaluate, it is to find the exact value of g of f of 2. Okay, so our question I, they want us to find g of f of 2. So we cannot find this one if we don't have what? G of f of what? Of x, which is just the same as saying g f of x. Okay, so let us first find g f of x. So when finding g f of x, we are going to start with the main function they've started with, which is what? G of what? G of x. So I'm going to write g of x is equals to the square root of 1 minus x squared. Now, g of f of x is equals to the square root where there is x, because here where there is x, it is where they've replaced the function f of x. So we're going to replace where there is x there with f of x, which is what? 2 minus x. So I'm going to have 1 minus, where there's x here, uh, I'll replace it with 2 minus x squared. Okay, that is what I'm going to have. So when I replace there, I'm going to just simplify it further to say g of f of x is equals to the square root of 1 minus, I'm going to expand what is in the brackets. Okay, so when I expand what is in the brackets, I'm going to have 4 minus 4x plus x squared. That is what I'm going to have in the brackets, like that. Then this negative is going to multiply with everything that is here, and you're going to have g f of x being equals to the square root of 1 minus 4 plus 4x minus x squared. So when you reach this part, you just simplify further and just say g of f of x is equals to the square root of 1 minus 4, it is negative 3, then plus 4x minus x squared. Now what you've gotten, this is just the same as saying g of f of x. It is not g of f of 2. So g of f of x, it is just negative 3, square root of negative 3 plus 4x minus x squared. That is g of f of x. Now, when you're finding g of f of 2, you're going to say it is equals to, where there is x again, because you can check here, where there is x, it is where they've replaced with what? With 2. So you're going to write what you've gotten here, which is negative 3 plus 4. Now, where there's x, you're going to replace with what? With 2. Then you're going to say minus, it's going to be 2 squared. Okay. When you have that, you just simplify further and just say g of f of 2 is equals to uh, the square root of, this will be negative 3 plus 8 minus uh, minus 4. Okay, which is just going to be, so g of f of 2 is going to be equals to the square root We know that this is negative 3 plus 8, it is positive 5. Minus 4, we're going to have a 1. As a result, g of f of 2 is equals to the square root of 1, which is just what? 1. And that will be your what? Your answer. Are we together?
Yes.
Okay. So this is composite function. So they can give you whichever function they want to give you. Okay. Depending, but make sure that you understand how to calculate the domain, how to calculate the range, how to calculate all those things, because they are the things that are going to be guiding your questions in your test one. Believe me, you're going to find this question in your test one. Okay, a question like the not this one, but like this one. So just practice more on it. It's a question which you're going to find there. So now let us look at two. Okay, let's look at 2. 2, they're asking us to find g of f. But we've already calculated for g of f, isn't it? Because g of f, it is just the same as saying g of f of x, which we've done what? We've already calculated for, which is we're going to go to just say 2 g of f, which is of x like this, is equals to the square root of negative 3 plus 4x minus x squared, isn't it? We've already calculated for this, right?
Yes, sir.
Okay. So we just get it and put it here because they want us to solve it. Now, the next question is asking us to find 3. Find the domain of g of f. Okay. So if they're asking us to find the domain of g of f, uh, it is this same function. So you need to understand how to calculate the domains of different functions. Okay, there are rational functions, there are radical functions, like this one is a radical function. So you need to understand how you can calculate uh, the domain of each type of function that you have. So looking at this is a radical function, and they want us to calculate the domain of it. So when you have g of f of x being equals to the square root of negative 3 plus 4x minus x squared. So this is our function. When you're finding domain, what you need to understand is that domain, it is just representing the x values. Okay, it is representing the x values that are going to be solvable for a particular function. Okay, when you plug in those values, they'll give you values that are valid. That's the domain. Okay, they are x values that when you plug in into a function, they'll give you valid function results. So in this case, here we have a radical function. So what you do is that in this radical function, for a square root to work, it cannot work on a negative number, okay? But it can work on 0, it can work on these other numbers. As long as it's positive, it will work on it. But the square root cannot work with negative numbers, okay? So meaning that our limit must be 0, okay? So meaning that negative 3 plus 4x minus x squared must be what? It must be greater or equal to what? To 0. Are we together?
Yes.
Okay. So it must be greater or equal to 0. So looking at the way this function is, let us solve the inequality that we have now. So let us
Sure, sir.
yes. So what we're going to do is that let us try finding the product. Okay, so the product of this one is negative 3 times negative 1, that will be a 3, and then the sum is equals to 4. Okay, and the factors, so the factors, so two numbers, when we multiply them, we get 3. When we add them, we get 4. What are those two numbers? Anyone?
It's 1 and 3.
Yes, 1 and 3. So we have these two numbers, and we're just going to, so I'll just, so what I use this number is I'll plug in where there is what? Where is the sum? Okay, because the sum is 4. It says here. It is the number that is with what? With x. That is our sum. So looking at this, what we have here, we're going to say that negative 3, then where the sum is, I'll just say plus, I'll get the 1, then I'll just add the x, meaning that I'll just have x. Then I'll get the 3, I'll say plus 3x minus x squared is greater or equal to what? To 0. So there I have this. So I'm going to factorize. When I look at this part, even this part, here there is what is common. Okay, and here what is common, we have, let me just arrange it in a proper manner, like the way uh, it is usually seen in books. It's going to be something like this. So I'm going to have, so let me just put where, so negative x squared, this one, then I'll go to plus 3x, then I'll go to plus x minus 3 must be greater or equal to 0, so that I solve it easily. So here what is common is, what is common here is x, okay, and it's negative x. Okay, so I'll just get negative x. So negative x is common. So negative x into x squared, it is going to give us what? X, because negative x into negative x squared, it is x, the negative and negative cancel, you're going to have that. Then negative x into positive 3, it is going to give you negative what? Negative 3. Then here what is common is positive 1. Then positive 1 into x, it is x. Positive 1 into negative 3, that will be minus 3. Okay, is greater or less than what? 0. Or is greater or equal to what? To 0. So here I'll get what is outside, which is negative x plus 1, and what is inside, I'll just get 1 because they're the same. So after having this, I'm going to equate negative x plus 1, uh, negative x plus 1 must be what? Must be greater or equal to 0, and then uh, x minus 3 must be greater or equal to 0. So I'm going to solve this one here. And when I'm solving this one, I'm going to have negative x. Okay, the one who go this side is going to be is greater or equal to what? To negative 1. That is what I'm going to have. And then this one I'm going to have, and this one is going to be x. The 3 will go this side. It's going to be like this. X is greater than what? Than 3. Okay. So here I'm going to multiply this with negative 1. When I multiply this with negative 1, it's going to be negative 1 times negative x, it will be x. Negative 1 times greater than or equal, it is going to be what? It is going to be less than or equal, because it is going to change because of this multiplication. Then negative 1 times negative 1, it will be 1. And x is is greater or equal to what? To 3. So when you're writing the domain, you're going to say that uh, domain so when you're writing the domain, you're going to put these values, because these are the valid values for what? Uh, for x. So x is what? X is less than or equal to 1. Okay? Then x is greater or equal to 3. So the domain, you just say that X is a member, oh, sorry. But when you reach here, they can even mark you because you are almost there. You're almost there. So what you're just going to say is that X X is a member of what? Of real numbers, where X is less than 1 and X is what? Is greater or equals to what? To 3. So this is your what? Your domain when you write it in what? In set builder notation. Are we together?
Yes.
Okay. Yes. So that is what you're going to write. So these are the only values that are. Then when you're writing it, if you're writing this one in if you're writing it in interval notation, you're going to say that the domain, you've seen that this one is saying that X is less than or equal to 1. Then this one is saying that X is greater or equal, assuming that there's a gap between 1 and 3. Okay. So when you're writing the domain in interval notation, you're going to say that what is your, so this one is coming from negative, so it's coming from negative infinity to 1. So it's going to be from negative infinity to 1. Okay. And so it's then this side I'll say uh the other one is from 3 to positive what? Infinity. 3 to positive infinity. So now, I'm going to unionize this because I'm putting them together. So it's going to be, do I include the 1? Do I include the 3? Yes, because of this bar which is at the bottom. So I'll say this one will be included. Then I'll say union, and then this one will also be included. Then I'll close like this, and this is my answer in what? In set builder notation. Oh, in interval notations. Are we together?
Yes, sir.
Okay. So there are so many ways you can solve inequalities. So like this, that's how you solve it. So now let us go to another question so that we can cover a lot of questions today. So our next question is saying that let f of x be equals to x over x minus 3. So they've given us the domain. X must not be equals to what? To 3. And it is a function. So now they're asking us to show that the function is 1 to 1. Okay. So uh, I, when a function is 1 to 1, uh, f of a is equals to f of b. Okay, that is one thing you need to do what? To note. So if a function is 1 to 1, f of a must be equals to what? To f of b. So I have the general function here, which is f of x is equals to x over x minus 3. That is the general function that we have. So this general function that we have, which is x over x minus 3, I'm going to replace, because I've said f of a must be equal to what? F of b. So f of a, I'll replace here with a, and here again with b. On the left side, I'll replace with a. On the right side, I'll replace with b. So it's going to be f of a, meaning that here where there's x, I'll put a. So it's going to be a over uh, a over x minus 3, okay, over a, or x minus 3. Oh, sorry, it's a. Here there is a minus 3 must be equals to b over b minus 3. Okay, so when this is the case, you're going to have this is what you're going to have. You're going to cross multiply. You're going to have your A multiplying with B minus 3. Okay. And then it is going to be equals to B multiplying with A minus 3. That is what you're going to have. So I'll multiply here. I'm going to have AB, okay, minus 3A is equals to AB minus 3B. Okay. So now I'll realize that here I have A minus B, or AB, and this side is AB. So you've seen that both of them are positive. So meaning that when one goes the other side, it is going to subtract and give us what? 0. So it's just better off you just cancel them from this side. Meaning that you're going to have negative 3A is equals to negative 3B. And then now, you realize that when you divide by the negative 3, you're going to have A to be equals to what? To B. So meaning that this function is a one-to-one function, because you're able to see that if A is equals to B, meaning that whatever I can find on A is the same thing I'll find on what? On B. So I'll just say, therefore, f of x being equals to x over x minus 3 is 1 to 1. Are we together?
So repeat on the last part.
Okay. So like I said, so I said that f of A must be equals to f of B. So now on f of A, meaning that this is a general function and it is the same function, I'll be replacing the A and the B. Just that this one will be on the left side, this side, and then this one will be on the right side, which is this side. So now, when I replace here, I'm going to have A over, so where there's X, I'll replace with A. So it's going to be A over A minus 3. Then this side, it is B over B minus 3. Okay, so I've just done cross multiply. I've had this. Then I've ended up having negative 3A equals to negative 3B because of the calculations. Okay, this is just normal calculations. This one can go this side if you want to solve it like that. You can take this one, this side, then they will subtract. But you know that this is positive, so I just cancelled them. So you have negative 3A is equals to negative 3B. Okay, so I've divided by the negative 3. I've just not shown it, but I've divided by negative 3. So I can just say this so that I show it. I'll just say divide the entire equation by negative 3. Okay, so that I have A to be equals to what? To B. So now, if A is equals to B, so for example, here where there is A, it's the same thing I have B. Okay, so meaning that whatever I'll get here of f of A, it is the same thing I'll get when I have f of B, because A and B are not different. They are just the same number. Are we together?
Sure, sir.
Yes. So that means that the function is 1 to 1. Clear? The one who asked?
Yes, sir.
All right. Wonderful. So now let us go to the second one. The second one is saying that find the inverse of the function and state its domain. Okay. So we're supposed to find the inverse of this function. So we go to 2. So 2 is you have f of x, okay, which is equals to x over x minus 3. So they want us to find the inverse. So when you're finding inverse, this is it's the same process you used to do at high school, where you just say that let f of x to be equals to what? To y. So when your f of x is equal to y, it is going to be y is equals to x over x minus 3. Now, you try by all means to make x subject of the formula. So, meaning that this side you're going to drop by 1, then you cross multiply. Then when you cross multiply, you're going to have xy minus 3y is equals to uh, x. Okay, that is what you're going to have. I've already done everything. So it's y is multiplying with everything that is here. So now I am making x subject of the formula. So meaning that those variables that have x, I'll take them one side. So I'll take the x this side. I'm going to have x, y. Then this is positive. It's going to come this side. It's going to be minus x. Then the negative 3y is going to come this side. Then it is going to be equals to positive 3y. So now when I have this, I can factor out the x so that I remain with y minus 1. Okay, because x into xy, it is y. X into negative x, it is negative 1. It is equals to 3y. Then this side I'm going to divide by y minus 1 because my goal, it is to make x subject of the formula. So I'm going to have this. Then I'll cancel this. I'm going to have x being equals to 3y over y minus 1. So when I have this, I just return back because now I've solved the inverse. So meaning that f of inverse of x is equals to, so meaning that where there is y, I'll return back the x, meaning that it's going to be 3x over uh, x minus 1. Okay. So now they've told me that I must mention the domain of the inverse function. So now when I have a rational function like this one, the way it is, I need to understand that uh, for a rational function, the denominator must not be equals to what? To 0. Because whenever I have a denominator which is equals to 0, it will cause me to have an invalid solution. So I'm going to say x minus 1 must not be equal to 0 because it is the only critical point that is making the function to be invalid. So x minus 1 must not be equal to 0, meaning that your x must not be equals to what? To 0 plus 1, which is x must not be equals to 1. There you have that function, or there you have that solution. So meaning that it is the only point that is making this inverse function to be invalid. Therefore, you're going to say that domain of inverse function is this. Uh, x x must be a member of real numbers where x must not be equals to what? To 0. So it's every real number can work in this function. Oh, so not 0, 1. So any number, as long as it is a real number, it can work in this function, except when it is equals to what? To 1. Then there the function is invalid. Clear?
Yes. Yes, sir.
Okay. So if you're using interval notation, you say or. You know that this one is coming from negative infinity to 1, where the same one is not included. Union 1 to positive infinity. You can also write it like this. Both of them are solutions. Okay. So this is set builder notation. And then this is interval notation. So 1 is not part of the solution. Okay. We continue. So now we have a function here. So this function now they're asking us to say, find the range of the function f of x is equals to 1 over x minus 1, okay, squared plus 2. So now they want us to find the range, okay. Now I like to solve these questions like this. Whenever I have a function, then they're telling me to find the range. I always apply this rule to say that domain of a function is equal to the range of the inverse function. Okay, and vice versa, meaning that the domain of the inverse function, okay, is equal to the range of the function. So the vice versa, what it means is that domain of the inverse function is equal to the range of the function. That is how it is. I'm sure you've seen this rule in one of your classes, right? They've mentioned it, some of you. How many have seen this? Okay, you can give a thumbs up if you've seen it in class, or maybe you've come across it. Okay, so this rule, it is what I like to use to apply when I'm solving questions on range and domain. Okay, because it makes my work easier. I don't have to think very much. So what I do, in this case, if I have, they ask me to find the range. So meaning that if I have a function like this one, my goal it is to find an inverse function and find its domain. When I find the domain of the inverse function, that domain of that inverse function will be the range of my function. So here I have f of x being equals to 1 over x minus 1 squared plus 2. So I know that I'm going to say let f of x be equals to what? To y. So meaning that I'm going to have y is equals to 1 over x minus 1 squared plus 2. So to easy the work, because this is a reciprocal, if I put 1 over y this side, uh, it becomes different. But let me not do that. Let me just solve it the normal way. Cross multiply, you're going to have your y multiplying with x, uh, x x minus 1 squared plus 2, okay, is equals to 1. Then I'll divide by the y. I also divide by the y this side. Then I'm going to have x minus 1 squared plus 2 is equals to 1 over y. So if I have this, I'll take the 2 to come this side because my goal it is to make x subject of the formula. So to avoid so many calculations here, I'll just say I'll take the 2 this side so that I have x minus 1, which is squared, to be equals to 1 over y minus 2 over 1. Then here the common denominator, it is y. Then y into y, it is 1. 1 times 1, that will be a 1. Then 1 into y, it is y. Y times the 1 times negative 2, that will be minus 2y. Then this I'll say equal x minus 1 squared. Okay, so when I reach this part, uh, when I reach here, I can do what? I can find the square root. And this square root is going to give two values, plus or minus. Don't forget square root, that's what it does. You've learned that in as you started. You learned that it gives that. So it's going to be x minus 1 is equals to plus or minus the square root. So you've seen what I've written here. It is 1 minus 1 minus 2y over y. Okay, that is it. So meaning that it's going to be x is equals to 1 plus or minus the square root of 1 minus 2y over y. So I've solved for the inverse. Okay, I have solved for the inverse. So here what it's just telling me is that since I've solved for the inverse, I'll just replace here. I'll say f inverse of x is equals to 1 plus or minus the square root. So since I've retained the x variable, meaning that where there is y, I'll replace with what? With x. It's going to be 1 minus 2x over x. That is what I'm going to have. So now, my goal now it is to find the domain of this function. Okay, so the domain where my concern is going to be, because here where there's one, it's not my concern because I know that whether it's I add the one or minus, it will be a valid solution. Okay, but my concern is on these numbers which are in the square root. A square root has a limit, okay, and the denominator must not be equals to what? To zero. Oh, yes, must not be equal to zero. So when I'm finding domain, I know the first thing I'm going to say is that here I have a rational function in a square root. And I know that my x, okay, so the first thing that I've noted is that x must not be equals to what? To zero, because when x is equals to zero, it's going to make this invalid. Okay, so to avoid that, x must not be equals to zero. Then now the other thing is that 1 minus 2x over x must be what? Must be greater or equals to 0 to satisfy the square root. Are we together? Are we together, everyone? Hello? Okay, some are okay, some are saying no. Okay, where have I lost you?
There where you were making x a subject to the formula.
Okay, where here?
Yes, sir.
Okay, so what I just did here is that I said let my f of x to be equals to y. Then I cross multiplied. Then I didn't multiply the y with everything that is here. It was just outside so that I can just divide it what? Easily. So I left it this side so that I can divide it easily. Then I had something like this. I ended up having this. Are we together up to this point?
Sure, sir.
Okay. So after I ended up with something like this, here I want to make x have the formula. I know I can expand this and I can have the two multiplying with everything, addition of everything like that, but it might also affect my what? My solutions. Okay, so to avoid all those complications, it's better since I already know that this one is it's a squared number. Okay, so I can just remove the two. I take it this side. That's what I did even here. Then after I did that, I had I found out that 1 over y minus 2 it is equals to 1 minus 2y over y. That is what I got. So now this side I had a square number. So if I have a square number, I need to square root it so that I can find the value of it. So when I square rooted, I found it that it is giving me two values, which is plus or minus the square root of 1 minus 2y over y. Are we together?
Yes, sir.
Okay. So after I had that, I ended up, after I canceled the square root, because here I'm going to cancel the square root. Okay. So when it is cancelled, meaning that I'm going to have x minus 1 is equals to plus or minus the square root of 1 minus 2y over y. So after doing this, I said that x must be equals to 1 plus 1, because the 1 now will come this side. It's going to be positive because I'm trying to make x subject of the formula. So I'll take my x to cut my 1 to come this side. It's going to be 1 plus or minus the square root of 1 minus 2y over y. Then now I'm returning back the inverse. So if I'm returning back the inverse, this tells me that my inverse, meaning that where there was y, I'll replace back with what? With x. So f inverse of x is equals to 1 plus y, 1 plus or minus the square root of 1 minus 2x over x. Are we together now?
Yes, sir.
Okay. So now, after we have this, I said that we are finding the domain, okay? Because I know that domain of the inverse function is equals to the range of the function. So here I'm finding the domain. So I've realized that there is a rational function in the square root. And this rational function in the denominator, my x must not be equals to what? To 0. So I'll say x must not be equals to what? To 0. It is a point which I need to note. Clear? Are we together?
Yes, sir, we're together.
Okay. So now, here again, you're going to realize that uh, if we have a square root of this one inside here, I know that it has a limit. It cannot work for negative values, okay? And the limit must be what? Must be 0. So meaning that 1 minus 2x over x must be greater or equal to what? To 0 for us to have valid solutions. So meaning that if I have this one is an equality, so for me to solve it easily, I'll just multiply with x so that I can cancel the x at the bottom there. So when I multiply with x, I'm going to have 0 times x, that will be 0. 0 times 1 minus 2x over x is going to be 1 minus 2x over x. Oh, that's cancelled. So it's going to be 1 minus 2x must be what? Must be greater or equals to what? To x. Oh, sorry, to 0. So when that is the case, I know that here uh, I'll take my 1 this side. It's going to be negative 2x, okay, must be greater or equals to negative 1. So here, when I, so let me just give an advice. So here, don't be dividing, like just dividing. Just, okay, you can say multiply. So let us multiply this by 1, negative 1 over 2, okay? But it is just the same thing like what you've been doing. Okay, let me just do that. But I wouldn't advise it to be a good practice, okay? Because this one changes depending on the sign which you're dividing, okay? That is why I like to do this. Let me just do it. Times, I multiply, so that I multiply the negative. So this is negative 2. So I know that I need to divide by negative 2, meaning that if I'm dividing means I'm going to say times negative 1 over 2. Okay, so which means that the negative 1 over 2 times negative 1, it will give me 1 over 2. Okay, then negative times this sign, it is going to change now. It is going to be like this because of this negative. Then negative half times negative 2x, it is going to give us it is just going to give us positive x. So meaning that x must be what? X must be less than or equals to 1 over 2. That is what you need to note. So these two are the key things that we need to understand. So when you're finding the domain, you're going to say that the domain for this case is that you need to understand that uh, x, because you can check here, x must be what? X must be greater, you've seen, right? X must be greater or must be less than or equals to 1 over 2. Okay, so it must be less than, so, and again it must not be equal to what? To 0. So the domain in this case, the domain is domain, you say x is a member of R where x must be what? Must not be equals to 0, and x must be what? Must be less than or equal to 1 over 2. And there you have it. That's what I like. I like writing like this because it's easy for me to understand it like this. Okay, are we together? Are we together?
Yes, sir.
Okay, all right. So now let us go to another question. So the other question says that determine whether the function f of x is equals to 2. So the function f of x is equals to 2x over 4x to the power 3 plus 3. So they want us to determine if it is odd, even, or neither odd nor even. Okay, so now uh when you're determining a function, if it's odd, even, or neither, I like to start with the even. Okay, if a function is even, meaning that f of negative x must be equals to what? To f of x. If it is even, if even. Okay, so now I already have my f of x. I already have my f of x. F of x is equals to this. So now what about if I have f of negative x? So now I'll say f of negative x is equal to, where there's x, I'll replace with negative x. So meaning that it's going to be 2 open brackets negative x over 4 negative x to the power 3 plus 3. Then this function is going to be f of negative x is equals to negative 2x over, this one is going to be negative 4x to the power 3 plus 3. Are these two equal? So this one is not equal to f of x. Are we able to see that?
Yes, sir.
Okay, so we're able to see that it is not equal to f of x. So if it is not equal to f of x, this tells us it is what? It is not even. Okay, now we test for if odd. If it is odd, if odd, f of negative x must be equals to what? To negative f of x. Okay, so we already have our f of negative x. We've already calculated for it, which is what? Negative 2x over negative 4x to the power 3 plus the 3. Okay, so this is our f of negative x. Now they are trying to say that this one will be equal to negative what? Negative f of x. So now before I use this one, we already have f of negative x. Okay, so let us find negative f of x. So it's going to, so negative f of x is equals to what? You get the negative and multiply it with the function f of x, which is what? 2x over 4x to the power 3 plus the 3. Okay, meaning that it is going to be equals to negative 2x. The negative only multiplies what is on top. Okay, then you are going to have that, or it divides only one, just one of these. It can either divide into that or multiply with what is on top. So meaning that I'm going to have this. Now, if I look at this, is it equal with this?
No, it's not equal.
So yeah, so we're able to see that negative 2x over 4x to the power 3 plus 3 is not equal to negative 2x over negative 4x to the power 3 plus 3, which is what? F of what? F of negative f of negative x. So therefore, this function, okay, which is f of x equals to 2x over 4x to the power 3 plus 3 is neither even nor odd. And you're done. Clear?
Okay.
Yes.
So there on the first part where we're proving when it's not even, the negative on the numerator and on the denominator, they can't divide, they can't cancel each other.
They can't cancel because this is one number like this.
Oh, all right, thank you.
All right. So that is how you solve it. Are we together, everyone? If I move
Yes.
forward? All right. So now let us look at this question. Okay, if time allows us, we're going to finish it. Okay, so now we have this question. It's a quadratic question, and actually, expect a question on this. Expect a question on this. Make sure you master this one, you understand it, how you solve it. You're going to expect a question like this. Check the past paper, check the past test one papers. You'll be seeing this question. Okay, even in your exam, I can tell you to, I can advise you to also read on it so that you understand it even more, because they also bring this even in the exam. So this question, they're asking us to say, let f of x be equals to negative x squared plus x plus 2 be a quadratic function. Then they're saying that by completing the square, express f of x in the form of f of x is equals to a, open brackets, x plus p, then 2 plus q, where a, p, and q are what? Constants. Okay, so when you're given this question, don't panic. What you just need to know is that you just have to get the function. So we have I, so we have the function f of x. Okay, so f of x is equals to negative x squared plus x plus 2. So that is our function. So they're saying that by completing the square. So now we know that when we are completing a square on an equation, we divide through the a. Okay, but this is a function. We don't have a zero here where the two can, or where the number that we're going to divide is going to go to. So what you do, you factor out the a. Okay, so in this case, our goal, it is to only remain with we don't have to have an a. The a value must we factor it out, and in this case it is what? It is negative 1. Okay, so you're going to write f of x is equals to, you factor out the negative 1, then you're going to have negative 1 into x squared. You're going to have what? You're going to have x squared. Then negative 1 into positive x, it is going to be minus x. Negative 1 into positive 2, it is going to be 2. Are we together?
Yes.
Okay. That is the first step that you do. So after doing that, because you factored out the a, so now here what you're remaining with, you are going to do what? Here you have so now since you factored out the a, meaning that this one is b over a, okay, the one which is here. So now here the one number which is with x, you do what? You half it, okay, and add it on, you half it and square it and add it and subtract it. Okay, so in this case it is -1. So I'm going to half this one by 2. So I'm going to have negative what? Negative half. When I half it, I'm going to do what? To square it. And then I'm going to add it and subtract it in this function. So meaning that I'm going to have f of x is equals to -1. Then I'll just do this so that I use some brackets inside. So I'm going to have x squared. I'll write everything that I have. X squared minus x. I've written everything that I have. Now, the one which I have halved, which is a number coming from this part, I have halved it. I'm going to say plus negative half. Then I'm going to square it. Then I'll say minus again the same number, -1 over half squared. When I do this, I've not changed the equation. Okay, I've not changed the function. It is still the same function, but I want to express it in this form. So when I do that, I'm going to have this. So the two now will follow like that. Are we together?
No, sir, you can kindly repeat on how you have the equation.
Okay. So you've seen that here, after I factored out the -1, I had this. Okay. So now you've seen that here, that's where the b is. So now after I've halved the, okay, this number which has remained, or the one with x, there's a coefficient. What coefficient is in front of x?
-1.
Yeah, so I'm going to half the -1. So meaning that I'll divide it by 2. So when I divide it by 2, it's going to be -1 over what? 2. Then I'm going to square that number. When I square that number, I'm going to place it back. I'm going to add it now to the equation which I have here, this function which I have. I'm going to add that same squared number, the same -half squared. I'll add it. I'll say x squared minus x, the way it is here. The way it is, I'll add it back. I'll write everything that is there. Then I'll just say plus half plus -half squared. Then again, I'm subtracting the same value, meaning that it's the same as 0. Okay, if you check here, it's the same as 0 because I'm adding again, I'm subtracting the same value, meaning I've not changed the equation, isn't it?
Yes, sir.
So now that's what I'm doing. I'll just say -half squared. If I'll then I'll subtract it again, -half squared. So now when I do this, you're going to realize that something happens, which is this. You have a square here, you have a square here. You're going to realize that it is going to be it's going to be a square. You're going to just get let me just do this. So here, let me just explain it like this than me explaining it. Here you're going to get like you've seen this value which is here, and this one which you have added, which is squared. You're going to get 1 here, x. Then here you're going to get 1 as well, which is -half. And then you're going to do what? To square it, meaning that you are done with this portion. Are we together?
Yes, sir.
So when you do that, you're going to say minus, then -half squared. So now -half squared is going to be 1 over 4. Okay, so we know that you're going to have 1 over 4 here. So 1 over 4, this minus is going to multiply with 1 over 4, so I'll just write it like that. Then -2 like this. Okay. Are we together up to this point, everyone?
Yes, sir.
Yes.
Okay. So I'm going to say that f of x is equals to negative 1, open brackets. I have x minus 1 over 2 squared. Then I have the negative. You've seen this negative. It will multiply. It was here. It's going to multiply with a 1 over 4. It's going to be uh, minus 1 over 4. Then here I have minus 2, mean that it's going to be minus 2. Yes, you are free to ask. Someone has raised their hand.
Sir, there where you wrote x minus half,
Okay.
like on the previous equation, wasn't it positive?
Where here? Okay. So the sign which I am considering, it is the one which is in the
Sir,
brackets, not this one. Yes. Yes, you are free to ask. I'm able to get you.
yes, sir, there. On that part, you didn't circle it, but it's x squared minus x plus negative half.
Okay. You've seen that it's written
So
plus.
we just left the negative.
You said plus negative half. So me, my concern is not what is outside. My concern it is what is only inside. You've seen it, right?
Yes.
So I'll just get 1, which is x here, which is squared. I'll say x. Then I'll get here I have negative x. So if there was plus, I would have said plus. But in the inside here, there's negative. So I'll just focus what is inside, which is negative half. Then I'll just close it and just say squared. It's a shortcut. Otherwise, you have to expand all of this, and then you just realize that you are going to come back to the same position. So to avoid all those long calculations, just get 1 here and get 1 which is here, which is negative half, and you write them, you subtract them, then you just square it. There you easy your work. Are we together?
Yes, sir, thank you.
Welcome. So now here you have this. So you have negative half, negative 1 over 4. Let me just solve it from outside. So negative 1 over 4 minus 2 over 1. The common denominator is 4. 4 into 4, it is 1. 1 times negative 1, it will be negative 1. 1 into 4, it is 4. 4 times negative 2, that will be negative 8. As a result, it will give me negative 9 over 4. Okay. So meaning that here, all of this, it will give me negative 9 over 4. So it's going to be f of x is equals to negative 1, okay, open brackets, x minus 1 over 2 squared minus 9 over 4. I have this. So remember the question was telling me to write it in this form. F of x must be equals to a x plus this was what? X plus what? X plus p squared, then plus c. There was a q. Okay, like that. That's what they want me to write it. So meaning that here, like the way it is, it's not complete. So meaning that now I'll return back the negative 1, multiplying everything here, meaning that I'm going to have f of x is equals to negative 1 times this is going to be negative x minus 1 over 2 squared, then negative times this is going to be plus 9 over 4. Are we together?
Yes, sir, we're together.
Okay, so that is how you write it in this. So this is just, you can able to see your a, we factored out negative 1. You've seen that negative 1 is in front, just I can't write negative 1 here. Okay, the 1 is invisible. So uh there it the a is there, you have the x plus p, just that here it's x minus 1 over 2, so it doesn't have to be plus. Okay, this that's a sign, that's just a sign, the general function. Then the square is here, then plus the q, which is what, which is this. Okay, all right, so you're done with the first one. I'm sure you can even get 5 marks for it. I think it's somewhere 4 or 5 marks. Yes. Then the next question is telling us to state the maximum and the minimum point of the function. So state the maximum and the minimum point of the function. So when they ask you to find, so this is two. There are two ways you can solve this one. Okay. Someone would just say, okay, why should I bother myself by, I can just write x is equals to negative b over 2a. Okay, then I find the value of x, then I'll just plug in so that I can do what, I can find the value of y. Okay, because the maximum values, they are x and y values. Okay, so I can use this formula. Okay, then as we are preparing, I'll also the next time I'll use another method. Okay, so here I can, or let me just solve it first. So in this case, I'm going to have x is equals to negative b. So I will refer to the original function which we had. The original function that we had this one. Okay, negative x plus 2. So we had negative x squared plus x plus 2. That is what we had. Okay, so I know that here I have my a, which is negative 1, my b, which is 1, and my c, which is what, 2. So I'll just plug in here. Negative b is what, it is 1 over, then my a is what, uh it is negative 1. Okay, so it will be negative 1 here. As a result, my x will be equals to what? To 1 over 2. That's my x max, either minimum or maximum point. So remember, if your a was negative, meaning that you're going to have a maximum value. Okay, that is what you need to understand. When your a was negative in the original equation, you're going to have a maximum value. So now the other way you can find it is that you've seen this one you've written here. Okay, is everyone able to see that?
Yes, sir.
Okay, so here you can just equate it to 0. Just say x minus 1 over 2 is equals to 0. As a result, your x is equals to 1 over 2. You can do that also. Okay, are we together?
Yes, sir.
You'll get it again. So that's why I said there are two methods you can solve that. Then now it's 2 points. Okay, so meaning that the original function also, you are going to say f of x was equals to negative x squared, since I'm using this method, plus x plus 2, meaning that when you have f of half, it is going to be equals to negative half squared plus half plus 2, meaning that it's going to be equals to, this will be 1 over 4, so it's going to be negative 1 over 4, and then this one will be plus 1 over 2, then this one will be plus 2. As a result, I'm able to see that it is just equals to 9 over 4, which is just this value here. Are we together? Or you want me to finish the calculations?
Yes.
Let me not jump. Let me. So it's this is the same as uh negative 1 over 4 plus half. It is 1 over 4 because they're going to subtract and get the sign of a bigger number, plus 2. Remember, you had something like this at the start and they were subtracting and you had the negative. Then just that here I only have positive, so meaning that I'm going to have a positive value, 9 over 4. So the maximum value for y, it is this component q. Are we together? That is the other way you can solve it.
Yep.
Mhm. So there you have it. So meaning that the maximum coordinates, the coordinates that you have, if you want to write the coordinates, they are uh, 1 over 2 comma 9 over 4. These are the coordinates. So you can see that this is a maximum point. Okay, it is a maximum point because of the value of a. Maximum value. So it is maximum value because of the value of a. So meaning that the graph is like this. Okay, those are things that you need to be noting down as you are solving. Okay, that's why they're even positive. You can check them out. But that this does not signify that it is a maximum value. You see how the graph will come out. So 3. So now they want us to sketch. Okay, so we have the function f of x is equals to negative f of x is equals to negative x squared, negative x squared plus x uh, plus 2. Okay, this is the function. So now remember, this same function has also been expressed to be written as f of x is equals to negative x minus 1 over 2 squared plus 9 over 4. It has also been written like this. Okay, so you can use either any. So let me use this one which we've solved. Okay, so if you're using this one which you've solved for, you're going to say that you're finding x-intercepts. Okay, so when you're finding x-intercepts, it is when y is equals to 0 or f of x is equals to what? To 0. So in this case, you have 0 is equals to negative x minus 1 over 2 squared plus 9 over 4, meaning that uh, this one goes this side, is going to be positive x minus 1 over 2 squared is equals to 9 over 4. Then you square root, meaning that x minus 1 over 2 is equals to, so this will be plus or minus, this will be plus or minus the square root of 3, the square root of 9, it is what? It is 3. Square root of 2 or 4, it is 2, plus or minus. So meaning that it's going to be x is equals to, the 2 comes this side, you're going to have 1 over 2 plus or minus 3 over 2. Then your x will be equals to, you get your 2, then 2 into 2, that will be 1. 1, so it will be 1 plus or minus 3. Okay, meaning that it is going to be, the first one is going to be x is equals to 1 plus 3 over 2. Then the other one, or and x is equals to 1 minus 3 over 2. As a result, you have your x being equals to 2 and x again being equals to negative 1. And the coordinates for this one, it is 2 comma 0 because it is an intercept. Then this one, it is negative 1 comma 0, which is also what? An intercept. Are we together on this part?
Yes, it's clear, sir.
Okay. So after doing this, so now I have the maximum value, I have the intercepts. So now let us also find the y-intercept. Yes, almost forgot. Y-intercept. So I'm using this function f of x is equals to negative x minus 1 over 2 squared. plus 9 over 4, meaning that when I replace here with a 0, because y intercept you get when x is equals to what? To 0. So f of 0 is equals to negative 0 minus 1 over 2 squared plus 9 over 4. Then this is going to be equals to negative. So f of 0 will be equals to negative. Then this will be negative 1 over 2 squared plus 9 over 4. Then this will be equals to negative 1 over 2 squared is 1 over 4 times. This is going to be negative 1 over 4 plus 9 over 4, which is the common denominator is 4, then negative 1 plus 9. It will give us 8 over 4. As a result, it will give us a 2. Okay, so meaning that the coordinates are 0, comma 2. Then now you plot. Okay, so when you're plotting, you write that the Cartesian plane, you're sketching. So now remember you have a negative 1 here, 0, then you have a 2 somewhere here from the y-intercepts. So these are points. Okay, don't forget. So now the other thing that you have is that you also have a y-intercept, which is 0 comma what, comma 2, which is, so I have 1 and I have 2 here. Okay, it's a point here. Then now there's a turning point, which is 9 over a turning point or a maximum value, which is a point which is half comma 9 over 4. Okay, we got this value. So you're going to get the half comma 9 over 4, which is a point somewhere. So there's 1 here, so the half is somewhere here. Okay, so the half 9 over 4, it is a point which is just slightly above here. Okay, as a result, this is 9 over 4. Okay, then this is the point. So I'll write them here. I'll write 1 over 2 comma 9 over 4, like that, so that you can connect the points. This point here, you connect it. Oh, sorry. So you connect the points here, another one there, another one there. As a result, you have this function, which is f of x being equals to negative x squared plus x plus 2. Are we together?
Yes, sir.
Okay, so you've seen that that is the maximum what? Maximum. This is the maximum. It's because of the x. The a is equals to negative, so meaning to negative. So it will be like this shape. Okay, it will make a frown face. If it's something like this, it will make a frown face. But if it's positive, it will make a happy face. You've learned this in high school. Okay, so that is about quadratic functions. Okay, so today we're going to end here. Okay, I encourage everyone to register. I surely encourage you. uh we are preparing your tutorial sheets, working on them. I encourage everyone to